started with our final presentation. I'm real happy to have the Webwork people here because I've never stopped and taken the time to really figure out what Webwork is. I know what it is, but I've never used it. So this is going to force me to get involved and figure out how I can use it myself to advantage in my classes. So Michael Gage is going to start. Jason Aubrey will tag in at some point, and turn it over to you guys. Thanks.
Okay, and thanks very much for inviting us. We're really pleased to be here, and it's really been very exciting. In case if you get bored, or if you're interested in practicing your multitasking skills, yes.
There's like a light that's directly shining on the projector screen.
Why don't we just turn all the lights off? That's the easiest
well,
way.
I mean, especially that light.
Yeah. Okay.
Because
that
light
light won't go off separately. That's the problem.
Are you serious?
Yeah, you have to turn them all.
Should.
Yeah,
if
you hit the notes thing, I think it turns on.
There's a
the lights up. Yeah.
That was half on. This is half on.
Be careful; those buttons are below the lights. The
Jason, you already good?
Well, whatever. That's okay.
Okay, this is half on. Then this is half on. There we go.
Yeah.
That didn't work yesterday.
Doesn't help a whole lot. But
Makes no difference. Okay, excellent. Much better for the projector, at least for the camera.
Okay. As I said, this is the central website for our wiki, and actually this is the splash pages for advertising Webwork. And if you put /wiki after it or go to the wiki documentation, you'll find lots of information about Webwork, lots more than I can tell you today. And so, as I said, if you get bored or if you're interested in multitasking, use that. Okay, so I assume that, as Rob said, that there are people who haven't used Webwork very much or haven't, so I'm actually going to give you a little bit of the spiel about when we tell people why Webwork might be good for your classes. So I'll tell you something about what Webwork is, its benefits for students. I'll show you something of our community, which is not that similar to yours, but not identical. I'll give you some demonstrations, and then we'll probably by that time I'll be answering questions more than I am sticking to the sketch, and we'll see what happens. So what Webwork is it's a web-based homework checker. It doesn't try and change the way you teach courses or anything like that. It just tries to make homework more effective. It was originally designed at the University of Rochester. Arnie Pizer and I started it somewhere around 1996. It's now actively supported by math and science faculty nationwide. And most recently, we've gotten an NSF grant joined with the MAA, and we're transitioning so that the MAA will kind of support this thing long term. In particular, hosting courses that used to be hosted at the University of Rochester for people who can't host their own courses, and so on. Here's what it does. When students are doing their homework online with this instant feedback and so on, the overwhelming majority of students complete their homework correctly. So it's homework, it's not quizzes. The idea is that if you didn't get it right, you get to redo it until you get it right. So eventually they get it right. It's particularly good at handling mathematics and physics. That's what it was designed for, and that's where it's most deployed at the moment. Could be used in chemistry for sure. But in things, more general things like Moodle and so on have not been particularly good at mathematics, and so that's where our, and the homework's really graded efficiently. So, our mission statement is to make the homework more effective. And the two things that do it, or the two things that are key here, is that there's immediate feedback. The students put in their answer and then they're told whether it's right or not. And you can configure this a little bit, you can give them a hint, but by and large the default mode is they're just told that it's not right and they have to think about it. And to some extent, particularly at the beginning of this project, when trying to figure out why they got the answer wrong and explain it to them was certainly beyond our capabilities in programming at the time. The idea is that if they're having trouble, they should be talking to a human, and so which could be their roommate or the RA down the hall or whoever it is that. The goal of the software itself was just to give them immediate feedback of, yeah, you're on the right track, in which case they feel good, they can go on to the next. And if they're getting it wrong, they should know this right away so that they're working on it. Yes, Jason?
So it's equivalent to just looking in the back of the book,
Almost,
Oh, okay.
except that, actually what it's equivalent, because if you look in the back of the book, then you know the answer, and then you work backwards from that, which is actually kind of useful. So it's equivalent to having your mother stand over and say, no, that's not the right answer, and then you say, why is that not right? I don't know, dear, but it's not the right answer. And actually, one of the important things for Webwork is something, I mean, the studies have shown that if you just use it, if you just deploy it, it won't necessarily make a big difference. So it's how you use it that really makes the difference. And I'm sure that a lot of the learning that takes place is in those environments where you get students, working in teams to beat the computer to get the problem right. And one of the reasons they can do that is because they each have this individualized version of the problem. So the answers are not the same. I mean, the differences are a difference in coefficients and so on. It's the same method. They can help each other learn how to do this stuff. But they each have to, they can't just copy answers. Other questions? Okay, and in big classes, it's actually quite efficient. So, even at a research university with graduate students and so on, we weren't grading all of the assignments. We were saying, do these assignments, and then we would give them quizzes and grade those. Now, all of the assignments are graded. And the result of this is the students, I can document that at Rochester, well over 95% of the students have got more than 95% of every single one of their homework problems during the entire semester correct. Again, eventually. And we have information, so we have information on performance. And it really changes, well, I'll get to the quote in a second here. Let me show you how it works first, and then I'll tell you a little bit more about that. So I've just got to do screenshots so we can go through this quickly, and we'll have demonstrations later. So here's a typical kind of question. And so notice that the answer here is, actually, I'm not quite sure. I think this is a typo. We want to define the derivative of x first and then find it at some particular place. Oh, no, I'm sorry. Here's where we find derivative. And then evaluate it at 1. And then you can restrict whether or not you're allowed to use the simplification things that are built into Webwork. So here's a typical kind of answer. A student's entered something like this. There's just a typo in the thing. So here's where they've entered it. So you get information that there's a missing closed parenthesis. This answer was correct. This answer would have been correct, except that we're in restricted mode here where you're not allowed to use the Perl as your calculating machine. So this is the kind of thing which I use a lot at calculus level, but people who are teaching pre-calculus or lower levels, they want to restrict the kinds of answers. And I'll tell you more about how answers are evaluated and so on in general. So finally, they correct these things, they get the green bar, they yell, yay, people. And as I said, you can Google it again if you're bored. There actually is a Facebook page on the green bar, Ode to the Green Bar or something like that. And it has, I forget how many members, but they were pretty proud of themselves. Here's another example. A lot of this is showing off relatively recent the technology model, meaning 3 or 4 years old now, that David Cervone developed, which parses the student's answer and it knows what context it's in. So for example, the idea of the context is this a point or is this an interval? Depends on the context you're working on. So David developed something called math objects, which, depending on whether you're in interval mode, interval context, or in a graph and point context, does the right thing. And what's more important, it automatically gives the right kinds of error messages to students. So, for example, it says the type of interval is incorrect here, because that's not the right thing. Here's just a comma, extra comma, so you have, it just tells you that there's a typo, things like that. So there's pretty good error checking in this. You can put lots of things in, and I'll show you more complete demos. These graphs are actually calculated on the fly. So as I said, these things are different for each student, and so they have different coefficients for what the graphs look like, and little PMG figures are made on the fly and served to different one for each student. Here's one in which you're checking to see what the limits are like. Things like that. Okay, so a little bit more just on the instructional thing. The thing that was really paramount in my mind, particular was if you're going to use, and this was around 1996 or so, if you're going to use computers for instruction, which I thought was potentially a really good idea, I wanted to make absolutely sure that it didn't change the kind of material that you were teaching. I didn't want to be influenced by saying, well, we can't teach that because you can't check it on the computer and so on. So we have, and of course you fail. I mean, there's some things that can't be checked on the computer. But we've done our best so that instructors really can ask most questions that they would typically ask from a calculus course in particular. And we have material all the way up to complex, the computational parts of complex variables and so on. We can't check proofs, things like that, or we don't even try. I mean, computers are good at some things and not good at others. But once you've, for example, in complex variables, taking care of all of the computational problems and so on, you and your TAs have a lot more chance to check the proofs.
You know about Lurch, right?
I do know about Lurch, and but I haven't.
Whether it would work with Webwork, I don't know, but just wanted to make sure.
I have heard of it, although I'd forgotten until you just reminded me. I talked to the guy who wrote it, and yeah, it would be interesting to put it in. So again, I'll tell you a little bit. Well, maybe now is a good time to tell you. The model for Webwork is actually very general. Your problem is a string, and it gets presented, and uses MathJax or JSMath or DVI PNG to present the mathematics. The student's answer is a string. And when you write the problem, you also write an answer evaluator, which takes the student's answer, which is a string, and spits out 0 or 1, depending on whether it's right or wrong. So if you have any algorithmic way of analyzing a string that can be written in a computer, any algorithmic way of analyzing a string and telling me 0 or 1, then we can put it into Webwork. Okay? It was
Perl.
Sorry?
This is why you like Perl.
This is why I like Perl. And this is actually, well, Perl was really the only choice at the time, but one of the things about, it turns out which was more important in analyzing students' math. Advanced computational abilities or abilities to analyze students' answers, parse them, give them error feedback, do all of these other things. And it turns out that the latter is much more important. The actual computational stuff is easily handled by nearly anybody, any language. And so Perl or something like it, now Python now has essentially all the capabilities that Perl does. Has been the important tool to use. But it also, because we set it up this way, in this very general model, the answer evaluators, as we call them, are very much at the edges of the tree. And so you can pick a new answer evaluator and plug it in. Sage could do that. We could shove, David can.
Yeah, I just wanted to point out that you actually can give a number between 0 and 1, but you can't give partial credit. So,
Right.
People may be concerned about being able to do that.
Right. And students are definitely concerned about it. So, and in fact, the hard part usually is not deciding whether the answer is correct or not. The hard part is if the answer is not quite right, figuring out how do you give useful information back, such as, it was, it wasn't formatted properly, or you were close but no cigar, or anything like that. That's actually where a lot of the work does. Now, and what happens for what we do have at the moment is lots of canned answer evaluators, written by many people, and so I said the most recent one's by David. So most people authoring problems don't have to invent a new answer evaluator. You just use the ones that are there. Yes?
Well, that was my question. So the function actually does pass more back than 0 or 1, because if it's incorrect, it gives you hints.
I was simplifying, but the original. But the point is that the evaluating a new answer is not central to the program. You don't have to tear out the guts and start over again. It's right at the edge, and it's built to have plugins. And similarly for grading, how you want to grade problems, partial credit, and all that kind of stuff. That's a plugin. Lots of things. There's a national problem library. There's 20,000 problems or so that have already been written. All kinds of things from pre-calculus up to probability and complex variables, linear algebra, differential equations, and so on. Not as much in physics. There's a little bit in chemistry. There's one high school teacher who's really interested in this. He's going to like the JMOL stuff. I'm sure. And finally, hosting for small mathematics courses, or actually any kind of courses, is available through the MAA, and there's a 3-year trial period. Michael Pearson will be here later and can tell you more details about that. But if you're interested in It's free for small mathematics courses. Actually, you can host any size you want, but then you get to deal with Michael there. They want to make the thing self-supporting. Yes.
How does the price compare to the price of WebAssign for the hosting service?
We're much better. So I don't remember the details of this, but and this is not set in stone. Not being a video here. But I'm just doing this from memory. But my memory was that if you were, for 100 students or so for a semester would be like $100, something like that, and $200, $500 if you've got a couple thousand students per semester.
It's a charge to departments. It's not
And the idea was to charge the department. So WebAssign is actually charging students X number of dollars, either hidden in the textbook or in
like $30 to $50 per student.
Yeah, it comes out to tens of thousands of dollars.
So the idea of MAA, I think, is largely to promote this, but if people want to be hosting courses on their server, they at least want to be able to break even in terms of administrative costs, things like that. And if it generates a little bit more revenue for helping development of further stuff with Webwork, that would actually be a good idea too. But yes.
Of course, you can download Webwork and host it yourself.
Yep.
That's correct.
Yep.
And some assembly required. But in fact, we've got, and I'll show you in a second. Yes.
So is the problem library fairly stable, so that if they put an assignment into a textbook 3 years later, it would still point to the same thing and be available, or is that, or am I not understanding it entirely?
Yes, and at the moment it's been very stable in the sense that but it's also a problem. The question is, how do you curate and how do you get good problems and how do you do things like that? So at the moment, what we've largely been doing is, usually the problems come in not one at a time, but from schools. So, we developed all these problems at school X. So we simply give them a branch in our repository and say, put all your problems up there, and that's how they're categorized, and they stay there. And the bugs occasionally get fixed in them. So that might happen.
And one interesting thing too about the Scrum library is that a lot of schools contribute, but now some publishers are starting to contribute. Freeman, most notably, is for the Rogowski textbook. They have commissioned somebody to write problems for their book, and they've contributed them. And they actually too are looking to hire like a system programmer to extend the capabilities. And then others like Wiley and Cengage have paid faculty to write problems for Webwork.
Right, and a bunch of, a couple of undergraduates in particular have helped with this. One was Sam Hathaway, who is responsible for a lot of the design, and he's the now head of software at Freeman, which is why Freeman's, Matt Betsy's another person. So students in general like this, and what they really like is the immediate feedback. And instructors like it also, for much the same reason, and this is where I was going to tell you while you're reading this. So one of the things that Webwork does, and why people use it even in small universities and so on, when they're not handling massive number of students, and when they meet students every day and so on and so forth, it really changes the kind of conversations you have with students. Students come into your office hour and they're not saying, I don't understand the chapter on integration, would you explain it to me? They're saying, I tried this problem on Webwork last night, I did it just the way you told me to do, and the computer won't accept my answer, and I want you to fix the computer. And in the early days, we fixed the computer. But now, mostly, you're now in a great position to say, oh yeah, here's where you went off, here's where you went off. And so it's a very different kind of interaction. There's also email facilities and so on. People will email in quick questions and so on. David has
I don't know if you're going to get to this later on, but one of the things you can do as an instructor is see what they have entered in the past. And that's really one of the, the trail of what they've done is one of the things you can use to help them.
That's right. And so in particular, when they email you a question, you get complete data of exactly what their problem is, and with a single click, you can go in and see not just the generic problem, but their exact version of the problem, including all of their answers. That could probably be upgraded a little bit, but because that was put in by David 7 or 8 years ago, and we haven't, we're still using that. So there's a lot of users. There's about 150 sites here. The blue ones are ones that are hosted. The red ones are ones where people have their own. And so this is on our wiki. You can go play with it yourself, see where everybody is. There's some international sites too that are using this. You can find your own pin.
That's an old map.
It is an old map. Yeah. So I think this is about right. We've got 151 that are listed they've actually told me they're using the server, and there's another 103 courses and so on which are hosted with the MAA. We expected there's about 300 institutions total using it. They don't always have to tell us. We have not been as good about things that weren't Sage Days 31. This was the Webwork Day 2, I think. This is a second gathering of programmers and so on at AIM, and in fact it was the week after I met you the week before, because you were at AIM. Bill.
Yes,
I
remember that. Yeah.
Right. You were at AIM, and we were there the week afterwards.
Yep. Yeah, and you showed up early.
Yep, I showed up early to try and get things set up. Okay, so these are the two URLs that you should be browsing if you're not listening to me.
Middle slide.
Sorry, what?
In the middle of a talk.
Well, I'm just doing something productive. So one of the things, so I am going to get to the demo, and we'll spend most of the time there, I think. But there's a few things that may not become immediately obvious I just want to call your attention to. One is that because of the way the thing is set up, the thing was set up in the really early days when looking at typeset stuff on the screen was hard work. And so we made it possible to typeset the entire homework set. And so the problems are written in such a way that they're either output in HTML or output in tech. They are not screenshots. So this typeset copy looks like it came out, the homework page of your textbook. I'm going to mostly.
I want to make a comment. You're saying this is old. From the way we have students doing online homework, a lot of them like that. Because for chemistry, we use a University of Texas system. And an awful lot of the times, the students print it out, actually, to work on the problems.
Right. And I actually encourage that because there are certain kinds of problems that you want students to work with interactively, but there are certain kinds of problems in math and chemistry, and so you want them to actually think about. And if you're sitting in front of the keyboard and you haven't hit a key in the last 10 seconds, you start to get antsy. And so, it's a... so that's one thing. Another thing is I actually encourage them to print it out and to keep Webwork notebooks so that if they start to do an answer to the problem and it's wrong, they can come in and they show me, here's, now I can see exactly what they've done. And also, and I tell them it's for their own sake, if they do everything in their head and on a calculator and it's wrong, they just have to start over again. If they've done it where they can go back and find their mistakes, they're learning really valuable lessons. I'm going to tell you mostly about the homework set mode, which, as I said, the homework comes up. It's individual for a student. It's a week from now. It doesn't change during the entire time. They keep doing it until they get it right, or until they give up. Or they go talk to somebody who helps them get it right. That's the idea. There is a gateway quiz mode, which I've also used, which is kind of more what you'd think it would be. You get 10 questions. You get an hour to do this kind of stuff. And then you submit it, and you're told what your score is. This is the University of Michigan for various purposes, and I've used it also. In addition to the homework set mode, just because working questions under time pressure is different from working when you can try as often as you want, and check and see whether your answer's been right, and try again. Each student's homework set is different, as I said. That helps with collaboration. There's an email and instructor button on each page where they can get quick answers to quick questions. Sometimes the answer is you need to come talk to me in my office, but sometimes you can see very quickly what it is that they're doing wrong and fix it. This is an old slide, so it's much more than 12,000 now. Just to give you an idea, and again, David is responsible particularly for the most recent versions of these answer evaluators. So you can check to see whether an answer, these are the canned answer evaluators. Real or complex numbers up to specified accuracy, any kind of function, including complex variable functions, numbers of functions with units, get the units right, and it's quite clever about the units, and I'll show you that. Antiderivatives, well, that's not well defined, but up to a constant. true, false, multiple choice, short answer, of course. You can even do, I mean, and the generalization of this is solutions to non-homogeneous ODEs up to solutions of the homogeneous ODEs. It's a simple linear algebra problem and it's solved that way. It was a lot of fun, right? Eigenvectors and parallel vectors and so on and so forth. Again, these are not unique, but these can all be checked. Independence of a set of vectors. So, you know, there's really a lot that can be done. Okay, get to the good stuff here. Actually, let me just do this down here. Can people see this?
Where your screen is now larger than the.
Whoa, how'd you do that?
I don't know.
Oh, that's
Just
interesting.
be aware that it's cutting you off just a
I
little
see.
bit.
The problem is a lot of people have their.
No, the projector's projecting
Projector is
wider
now
than
projecting beyond the screen.
Oh, that's
So
impressive.
somehow you switched resolution.
I don't know how I switch resolution on this thing.
So do I need to fix the projector again?
No, I think this is okay. I can.
It's easy to zoom in and out.
I think what I did is I just made this larger so that you can see it. Here.
I definitely.
Okay. Okay. So here's the kind of question you can ask. Just fairly easy one. You submit answers, and I pre-put the answers in so I wouldn't embarrass myself trying to answer these things in no time. You know, there's some tooltips that allow you to see what was entered. Actually, doesn't make much difference here, but here you can see the actual number that was entered, or for the answer preview and so on.
So you're able to use Webwork as a calculator here. You got
Yep.
the square root.
Yeah, and in fact, I'm going to show you mostly calculus type stuff in which we turn that on all the time. I mean, if they can't do calculations at this point. And this is the site that I sent you. Here's the site to look at over here. So again, if you're through browsing Wiki, you're fast. There's a lot in it. You can now amuse yourself by going to this site here, https://hosted2.webwork.rochester.edu/webwork2. That's the way all the sites start. And then I'm on MAA 101, so don't use that right at the moment, but MAA 102, 103, 104, and so on and so forth. And you can sign in as students, as student 1 is the login, and the password is student 1, or as professors, professor A, and the /prof A. And try and pick some random number between, say, 101 and 130. Because if two of you are on at the same time, you'll log each other off. So if you're being logged off, that's one of the disadvantages of having a public server like
Got
this.
117.
Okay, yeah.
What's the difference between Prof A and Prof A?
No, one's the password.
One's the login and one's the password. They're identical. Prof B works too. And I'm not sure student 2 works. If they don't all work, and again, while I'm on it, so first of all, these things are there for you to play with and see what it looks like from the inside. If somebody's really interested, I can set you a course up on that hosted 2 machine. It takes me about 5 minutes, and you're welcome to play with it for. It's not being used. So, okay. So here's an example, and let's see.
Of course, when you log in as a student, you may not edit this problem or show correctly.
Oh, so he's logged in as professor right now.
Yeah, I'm logged in as a professor and so on.
And we can try the problems.
Oh, okay, I don't know what. So notice the error correction. See, there's the missing the closed parentheses and so on and so forth. Down here at the bottom, it's telling you that this time. Oops. Yeah, so 67% this time because I got one answer wrong. My overall score is 100 because I got it completely right once before. It sticks at the highest. Students would complain if it didn't. Okay, so here's an example where you've got a graph. You can't quite see that, so let's make it a little bigger so it shows up. So you need to figure out limits just from looking at a graph.
So how do you draw this graph?
So the graph is drawn on the fly. Okay. I've drawn it as a kind of piecewise linear this is one graph, this is another graph I draw where the points are and so on. The points are all picked at random, and the graph is drawn on the fly for each student. So each student will have a different graph, everything's on the fly, nothing's saved here.
It uses GD graph.
Yes, this is, sorry, that was the answer.
No, all those are the answer. Good. Okay.
And so you ask for answers to this thing, and you submit them. And, so here's interesting. So I put none because there's no limit at this point, and it doesn't. So this is clever enough. Again, this is David's work. It's clever enough to realize that well, none just isn't one of the answers I thought of. And so you have to, it said enter DNE. So I'll enter DNE, but since I didn't read directions very well, I entered it in lowercase. But that's good. Okay, and I still got something incorrect, but I'm going to fix that. Again, you can go play with this yourself. So here's one where you're supposed to take the derivative. I showed you the kind of thing that this works with before. Okay, that's how that works.
I really like that you put exactly what they entered and exactly how it's interpreted, so they can tell if it's a formatting problem or if it's a...
That's right, and in fact, I'm glad you brought that up actually, because the answer preview here solves lots of things, particularly with fractions and so on, where people are confused about 5 over 2 times 2 is not is not 5/4. And in fact, there's some controversy about this because these things are actually available now as tooltips, and I was thinking you could get rid of the answers, but Arnie violently objected to that, so the answers come back and it's now configurable and you can either leave it there or not. So I was really proud of the tooltips, so I guess I tried to get rid of it as the result of that. So here's an example here. And since as a student I always tried to break things, this is actually a correct antiderivative to this thing. Since this is the antiderivative and I've added 1 to it. Right? So this is the kind of thing where I would do this and then explain to my professor why, I deserved the computer was stupid and it wouldn't accept correct answers and so on. So
it did.
Well, so I designed it. So so a lot of people have been fooled by this, and they say, "Oh, well, wow, you got really good symbolics behind this thing." But of course, we don't. This thing's interpreted as a function, and the professor's answer is interpreted as a function. And what we do is, well, in this case, we say 2 functions are equivalent if they're. So first of all, we evaluate them at one point and we see how they differ, and that tells us what the constant's supposed to be. And we adjust for the constant, and now the 2 functions are equivalent if they're the same on 5 points, which any mathematicians knows is not correct, but it is actually correct for all calculus functions. And particularly if you randomize the points that you pick and so on. We've gotten more troubles with cases where you have false negatives because of round-off error than you have.
And you allow the square to be sort of cosine?
Yes, that's, again, David's doing in the parser. The original thing didn't allow that, and also you had to have stars in between things, and so on. And in fact, you can put those back if you really want. But, yes, David.
If you look at the entered value up there, you'll see there's a lot more parentheses and stuff there. I tried to make it clarify what the interpretation was for the students so that they knew what they should have been typing had they wanted to be explicit about it.
And it's just modeling it for them as well.
Yes, that's right. There's an awful lot going on. I'm only going to kind of get
If you go to the pop-up, does that show exactly what they entered? The tooltip, or does the tooltip show the same thing as the enter?
This is going to show the same
thing. Because what would be neat maybe is have entered, interpreted.
Yeah, I mean, there are way too many things to actually show up there.
Yeah, but that would be, because I agree, when my students are entering things, they really run into these syntax issues. They have the same problem in their calculator just for doing numerics. They forget the parentheses or showing them, here's what you put in, here's what it was interpreted as, here's what it looks like in math notation.
You can actually look at what they put in.
Yeah.
Below here.
So
that's
right
true.
there. Okay, sure.
Right.
That's
so,
an interesting point. It
yeah,
is there.
and so there's a bunch of things that could be done. A lot of this stuff was again designed when your screen looked like this, and so real estate was a real premium, and that's not so true anymore. So that's one thing you can change. The existence of things like tooltips and so on means you can put much more less important information in ways that would help you.
Actually, that's
and
what I
the
would do.
third thing that this was done on the basis of research that Vicki Roth does the analysis of how students are reacting to this kind of stuff. The biggest single complaint was I knew how to solve the problem, but I couldn't enter the answer properly. That's the general thing, or the computer didn't accept my answer even though I entered it properly, which is the US they usually say. Putting in, so we put in this answer preview, which is not quite real time, but there is a preview button down here, so you can preview your answer without without actually submitting an answer, if that's of importance to you, and having the stuff typeset and sent back to you reduced those complaints practically to zero. And it works really well. It really, I mean, people still want a keyboard entry type thing with square root signs and so on. I'm kind of personally reluctant about that, but particularly below calculus and so on, that might be more important. But this thing goes a long way to solving that kind of that problem. Yes.
So what Robert brings up, I mean, now we're seeing the prevalence of mobile devices. I can see a lot of students, and all of a sudden screen real estate is now again a premium.
That's
and
right.
Keyboard issues are a big issue too.
And keyboard is, and so I actually think that the keyboard thing is I mean, as I said, I've resisted it, but iPad has made me change my mind again. I think a keyboard, a specialized, if nothing else, a specialized keyboard entry, so you don't have to keep switching.
Right. Just for parentheses or whatever.
Just to get parentheses or an up arrow or something like that. So there's a lot of this is nonstop. You can keep upgrading the user interface because the thing keeps changing. So. Okay, next. I told you, meters. Okay, so the physics people want to have everything in units, and I'm getting. But of course, what you really want, even though the problem used meters throughout, I claim that's the correct answer. Unfortunately, the computer does too. And there's a little bit of, and you can put it in miles and inches and hectares, whatever is correct. Yes?
Yeah, as a scientist, let me make a comment about this, because I was thinking about the units package as it's been installed in Sage. I don't use it. The way I do units is I simply set up I set up variable names, and I use those as the units, because of course the way in a physical calculation you handle the units is they are just a multiplier on your number.
And that's exactly what this is. That's exactly how this is implemented.
Instead of having to interpret units as something special, you just carry around that variable name, and it's just a multiplier.
That's how mathematically does it. I thought that's similar to how
exactly the same as
well, except that you end up saying dot unit something. Where when I write the equation, I say 100 times centimeters, or 100 times meters, and I define a centimeter is equal to 0.1 meters.
But I mean, it's literally exactly the same as what was implemented, except
that entry's more difficult. It's not the way we think about it.
So
that's basically what. Now, the way he's got it, so you can enter it with a space, and interpreting it as multiplied by also works. But this is a real issue for usability for people who do numerics.
And there are some restrictions on that. So, for example, you have to have all of the things in the numerator and then divide it by all the things in the denominator. It's not completely general. You could parse the thing more thoroughly. I don't think you can fix that.
We never have made the full units package.
Yeah. So, but and everything just goes back to kilograms of basic units, and everything else is defined in terms of those, and just the new multipliers. And you can augment it any way you want. So here's an example of something. You're supposed to find the function, which of these graphs is the function, which is the first derivative, and so on and so forth. It's surprisingly difficult. And I made it easy so I can remember the answer. No, actually, that was just how it randomly came up One thing, again, in using it, this will be different in different cultures, but at the University of Rochester, I've had students who come in, obviously they can get the answer right by just the right number of times. Yeah. I've had students come in and said, you know, I got the answer right, but I still don't understand it. Will you explain it to me? And again, the real thing about this is that it catches the student's attention, and then the real education probably goes on either in their thinking of it, or they're talking to somebody else about it, or they're helping somebody else with their version of the program and all that kind of stuff. Without that human interaction, I mean, they don't learn just by this.
So if they feel like they're not confident on this one, can they try another one that's randomly generated?
Yeah, that's
correct. Or do they keep getting the same one over again?
They keep getting the same one over and over again on this one.
Even if they get it right?
Even if they get it right. So there's other ways in which you can generate things randomly. So first of all, you can set up a problem that does that. We also have what our guest logins on all of these pages are available to students too, and they get a different random thing for that. And you could make it up. You could make it up as practice.
You can also assign the problem twice.
I'm sorry?
They have to work the problem twice.
But if they felt like they needed extra practice,
well, yeah, what you want is an option for them to say, I want another one.
And in fact, that's been requested. That isn't implemented at the moment. It could be done, yes.
There is a macro package to let you do that, but you have to write it into the problem. It's not something that's
That's right.
Okay, so you can set
up a problem to do that.
Yeah, you could set up a problem that was just.
You know.
Yeah, give me another one. I like this. So this is what I decided to call an oracle function. Because, you know, if you ask it what's its value at 2, it tells you. And if you ask what's its value at, say, it's 1.9, it tells you. It's all JavaScript. And the students say, well, so how the hell am I supposed to figure out the derivative, because I can't bring down the exponent? So now what do I do? I've even had some instructors say that when they went on this thing.
Use a calculator, that's what it says.
Yeah, no, this calculator, right, actually that's right. So see, I didn't actually feel like doing my arithmetic. Well, most students would do it with a calculator and then enter the thing. But you know, just, and this is an example of something that cannot be done in a textbook. So, and it's just JavaScript. So this demonstrates in spades the fact that no standard program is going to have checks for palindromes. So all I did was to write a little check for a palindrome that gets put in. So you know, enter a palindrome, and you know, it likes that one. It doesn't like this one because the capitalization. This one didn't care about capitalization. This one did care about capitalization. And so this is what move this over a little bit. This is what the source code looks like. So there's boilerplate at the top. This is a fairly old problem, but it shows you the ideas behind it. In fact, this is one of the first problems I wrote when I designed the thing. So here's where the text is, and then here's in Perlish stuff. This is the standard palindrome test. So it says take the student's answer and then figure out whether it's correct or not, and then there's a few things to give them information about. For example, we have the string concept of the palindrome and so on and so forth. So right inside this problem itself, I wrote. There's an example of embedding an applet in the page. This was by Frank Blackberg. This is what's called the light applet, and this is an idea that I really like. It hasn't been utilized enough. The applet does, the only thing that it does is it presents a picture, and it allows you to move this cursor around. Yeah, it's a little 2D interact type thing, and you can see where the X and Y pixels are up here. And the question, so I actually consider this for pre-calculus type of thing, which I don't teach, so I haven't had a chance to use this, a really great question, despite its simplicity, because how far is it from Kandahar to Kabul? Well, obviously you have to use Pythagorean theorem. You know, I have to figure out where, this was done in West Whitehead, which is why quite a while ago, but we're still there, so it's still relevant.
butter button.
So how are you going from kind of having to well, so you go, all right, so you got to figure out where x is, and you got to figure out what y is, and you got to go from here to here. And I didn't answer this question, but okay, so you figure out what x is and you figure out what y is. You do Pythagorean theorem, and you get your answer and you put it in here, and it's clearly wrong. So how? Yeah. So that's the point. So that's in pixels. You got to use the legend, figure out what the conversion is, and then you got to put the conversion is. If I remember right, you have to put the units in too, or if not, you can make it so you have to put in the units. And you're allowed to use either kilometers or miles. You just have to put in the right units. So that's like a 3 or 4 step problem. That's pretty good for automated problem type of thing. You can actually get some students to think quite a bit about while they're doing that. Here's another version of the same thing. And here's the tour de force. This is one of David Simone's problems that he did early. And so this is matching contours with surfaces. And again, so these are pictures here. These are not drawn on the fly. These are standard mathematics objects and so on. Okay.
What does it use for the 3D?
The 3D, this is LiveJar, if you remember that.
Live graphics 3D.
Live graphics 3D, right.
It
takes Mathematica and plots it. So this is from the early 90s or something like that. This Applet.
Is that a screwy license or something? Is it the one with the screwy license? Is that the one with the screwy license?
No, I don't know exactly what its license is.
So it's considerably more lightweight than JMOL, but you can put JMOL into these kinds of things too. Applets, as you know, Java applets in particular, are kind of heavyweight, and so you can have some. So I'm going to skip I was going to show you something about a regular first semester course is what some of the standard problems look like. I've been showing you the show-off problems, but I'll skip that right at the moment. I think if that's okay.
Which one is that? If we're browsing the site.
Well, no, actually, well, all right. I will show you for a minute. So this is, and you can get into this as a guest. This is HTTPS, and then it's math.webwork.rochester.edu/webwork2, and then you will see at that point you will see all of our courses that we're offering. And all of them have guest entries, and so you can go in, you won't see it as a professor, but you'll see it as a student, and you can see what the problems look like. So I just,
It's free for non-commercial use, closed source.
So if you just click the guest login here, I'm sorry, I'm already logged in as a professor, so it thinks I'm trying to do something.
You have to get a license from Mathematica.
But if you log in as guest, you'll see all of this stuff without all this stuff on the left-hand side. Okay, one more show-off thing before I stop here. Give Jason a chance with some of these things. So the question here is, suppose you wanted, the question is, give me something like a function that increases on this interval, decreases on this interval, increases on that. Show me what the graph looks like. You can think of this is the demo problem, this is not work. Okay, so you're supposed to manipulate this thing, which is a Java applet. This is done by David X, again in the late 90s. So it's actually been around for a long time. This is a nice kind of interface for students. You move these bars around, and then it interpolates between the two and see whether or not you got the answer correct or not. Let's hope this thing doesn't hold up too long. And
what do you come for the correct answer? What do you show for when they ask for a show correct answer?
Well, at the moment, this is just a demo type of thing, and I'm worried whether what's going on with Safari here. It forced me to first click it. Okay, there we are. So here's the answer. It's increasing. It's incorrect. It's increasing on this region. It's decreasing on that. A lot of this stuff could be improved. This is demo type stuff.